Hello and welcome to SudoKanard. As you can see now, you can see my face on my videos. That's modern SudoKanard. And for the occasion, I'll be solving this bus Sudoku puzzle that was featured on WPF Sudoku Grand Prix, round 1. That was the highest pointer on the round. I think it was 109 points. And I didn't think it was that difficult compared to other puzzles with less points. So the rule is that whenever you have a number outside the grid, it says that that number of digits has a total sum over 21, meaning 22 or more. And that's the first time we have such a number, meaning that the first 4 digits, in this case, must not exceed 21 points. So we can have at most 21 here and at least 22 here. So that's the rule, and obviously the usual rules of Sudoku. Alright, so let's start. And the first point is here. Those 6 digits must not exceed 21. And if you're familiar with Exam Sudoku or let's say Killer Sudoku, you must know that the minimum sum of 6 digits is precisely 21, meaning that those are the digits from 1 to 6. So I won't pencil marks 5 candidates in those cells, but we know that those must be 8 and 9, and there's an 8 here. So we can enter 8 and 9 right from the beginning. And now this 7 is fulfilled. Next, I have a look at 3. So this must be at least 22. And there again, if you're familiar with Exam Sudoku and all that stuff, or Killer Sudoku, you must know that 22 or more with 3 digits requires a 9. So I know there's a 9 in one of those 2 places, and it's the same up there. There's a 9 up there. Another place of interest is this row. We see that those 4 digits must have a total of at least 22, and those 4 digits as well. So those 8 digits have a total of at least 44. But it's a well-known secret that the sum of all digits in the row must be 45. So this can only be a 1, and we know that the remaining sums here must be exactly 22. Something else is here with this 5. We now know that this is at least 22 and this is at most 21, but the difference is exactly 1. So there again, this must be exactly 21. So this must be exactly 17, but there are lots of ways of doing that. So where should we look? Not sure. Perhaps. Oh yes, so those 3 digits must have a sum of at least 22. But we can see that the available digits are 9, 7, and 6, and that's 22. So those digits must be exactly 6, 7, and 9 in some order, and this one is not a 6. And we can see that the remaining 4 digits must be 1, 3, 4, and 5. So 1, 3, 4 here, 1, 4, 5 here, and I won't pencil mark 4 candidates. But something interesting here is that we have 2 pretty high digits here. And we know that the sum of those 5 digits can't be more than 21. And you can see that 21 is actually the minimum value for this sum. If I put a 7 here and 1, 2, 3 here, that's 21. And I can't exceed 21, so this has to be a 7. And those have to be 1, 2, 3. And this one is obviously not a 2. And now this is a 5. And we know that there has to be a 4 in one of, oops, sorry about that, in one of those two cells there has to be a 4. So that's good progress. And we now know that this 6 is fulfilled. And the remaining digits must be 4, 5, and 9. And because of this 5 and this 5, 5 in this column has to be here. And those are 4 and 9. This row needs 1, 2, 3, and 5. So those are 1, 3, or 5. And there's a 2 among those two positions. Now let's have a look at this. This 6 means we must have at least 22 here. So at most 23 here, but well, there's room. There's plenty enough room to have less than 23 here. But this must be no more than 21. And we already have 11. So the remaining 3 cells must be no more than 10. So I think it must contain a 1. If I don't put a 1, then I get 3, 4, and 6, which is 13, and it's definitely more than 10. So there has to be a 1 in one of those 3 positions, and this can't be a 1. And the interesting part is that it can't have both 3 and 4. Knowing that the minimum possibility for those 3 cells is 1, 3, and 6, and that is 10. With 1, 3, and 6, which is the minimum option, I get 21 here, so it must be 1, 3, and 6. So I put a 6 here, this is 103, this is 103, and now this is a 4, and this is a 7. And this 6 clue is fulfilled. Something interesting here is that we have 1, 3, 5 triple. So those 2 digits now must be 4 and 6. And it removes 4 from this cell. Well, actually it was already removed because of this. And here we don't have a 5, so the candidates are 1, 2, and 3. And here we get 5, 8, and 9. And I think this puts pressure on this sum, which has to be 21 exactly. We already have 10, so the sum of those 2 digits here must be 11. 5 would require a 6, which would repeat. 8 would require a 3, which is already in the column, so this has to be a 9, and this is a 2. The rest of the digits are 5, 7, and 8, and I can remove this 5. This can't be a 1. And we know we must have 22 here. 22 with those 4 cells, and this is a rather small digit. If this is a 2, that's 7, I need another 15, which can only be with 7 and 8. And this would never be a 7, so this option puts an 8 here and a 7 there. And the other option with a 3, that's 8, I need another 14 without using the 9, so that's 8 and 6. And in this case I get 6 or 8 here, and 6 or 8 in this cell. And that's not such a big restriction. Where else could I look now? So there has to be a 4, and a 2 or 3 and a 6 or 7, something like that. This column needs 1, 2, 3, 4, and 6, which is not that interesting. What should be the next place to look? Perhaps this 6. Those 5 cells should not exceed 21, and we already have 2 somewhat big digits. Perhaps not so big. Should I do some Sudoku? So this must be at least 22. So this shouldn't be too big. And this shouldn't be more than 23. And we already have at least 7 plus 6. That's 13 plus 7, that's 20. So this won't be more than 3. Oh, that's interesting. It has to be a 1. I can remove this one, and this is a 1, this is a 3. Let's consider we already have 8, and this plus that won't be more than 15. So it won't be a 9 and a 7, for example. It won't be a 9 and an 8. Well, I don't think I can find more with that for the moment. Where else should I look? Oh, this 3, sorry. This 3. It must be at least 21, and we have big digits here. We must have at least 22. And we have big digits. So there has to be a 7 or an 8 here. We can't make 22 without using a 7 or an 8. So there's a virtual 7-8 pair here, and this has to be a 5. So there's a 7 and there's a 7 or an 8, and the remaining digit can only be a 6, I think. It won't be a 4. With the 4, I can't make more than 21. So those digits are among 6, 7, 8, 9. So this is not 6 or 9, so it has to be 7 or 8, and this is not 7. This is a 6-9 pair. And here those digits must be 1, 2, 4, which places a 3 on top. This is now a 1, this is a 2, this is a 3, and I can remove 3 from those cells. So that is some progress. And so this 3 clue is now fulfilled. And this 6 now, we have only 7. But I think it's okay. I mean, we must not exceed 22. So I think I can't put a 9 here. If I put a 9 here, that's 16. That's at least 22 with 5 cells, but it takes 6 cells to exceed 22, so 9 must go here. This is now 5, 6, or 8. So that's 7. Plus at most 8 and 6, which works. That's 21 at most. So this 6 is now fulfilled. And I know there's a 6 here. Well, I already knew that because there's a 6 here. So what is the next point, the next place of interest? Perhaps this 1, 2, 4 is interesting about this. Not so sure. Well, is it about here? Don't think so. Perhaps this 5. not so sure. There has to be a 3 and a 4 there, but I don't see anything to do with that. Well, let's... This is one of those bobbins movements. But during the contest I had already broken the puzzle. I had put a total of 22 here, which was not good. Well, let's have some more look about this 3. So we say this 4. We say that those 5 digits must not exceed 23. So this and that must not exceed 15. So there has to be a 6. But that's not useful. We already know there's no 6 here. And I don't think I can make any more deduction of that. Let's have a look at this. We already have 11. We need no more than 10 here. No more than 10. So I wouldn't put an 8 here. So no more than 10. That could be 1, 2, and 7. So I could have a 7 here. But there are other options. Oh, this digit here. It's not 1, 2, 3, or 5. So it's at least 4. And at most 7. It can only be 4 or 7. That's not such a big restriction. If it's a 7, then I get 1, 2 here and there. If it's a 4, then this can be 1 or 2. Let's imagine I make this a 4. And this is not a 4. So this is 15. And this plus that can't be more than 5. So this has to be 1 or 2 in this. So this one has to be 1 or 2 in this scenario. And what I was saying is that if this is a 7, then this and that have to be 1 and 2, have to be a 1-2 pair. So this has to be a 1-2 pair in both options. That's interesting. So that's 9, 14, 18 or 21. And in both cases, this goes over 21. So that's good. So this is now fulfilled with this 1-2 pair that was unexpected. And this now can only be a 3 or a 4. And this can be 3, 4, 7, or 8. No, it can't be a 3. Oh, 3 can only be here on this row now because of this. So now I still need 1, 2, 4, 6. So this is 4, 6. 2, 4, 6. 6 is still possible here. So I remember not writing down all possible candidates. So this is 4, 7, or 8. But now, how do I make 22 or more with 4 digits? I'm sure those 3 won't exceed 21 because there's a 9 here. How can I do that with a 1 here? 10, 8 and 4 would work. Am I missing something? Probably. I'm probably missing something. Not something obvious, I think, but something nonetheless. Because of this 4, there has to be a 4 here, so this is not a 4. That's not huge progress, but that's something, I guess. Is there something about this 5? I don't think there's anything. Maybe I should have prepared for this video. And as you know pretty well, I never edit my videos. I'm much too lazy for that. Oh, that's embarrassing. Okay, so with these 2, the scenario was 7 and 8, to have a total sum of 22 here. That was typical canard. So this is not a 6, this is not 4 or 6, and those are 3, 4, and 6, and this one can only be a 3 because of 4, 6 pair here. This now is a 7, this is an 8, and this is a 7. That's a 4, that's an 8. This is not an 8, but this is 5, 8, 6. 4, 6, and 4. And this 3 now goes here. This is a 5. That is progress. I get a 9 here, a 4 there, 6 here, 9 there. And this 6 here goes here. It fixes 9 and 6 on top. This 9 puts a 9 here and an 8 there. Here we need 1, 2, and 5. So this is 1 of 5, 1, 2 of 5. We get 1 5 pair in this column. 8 goes here, that's a 7. Down there, that's an 8. Here 1, 2, and 7. And here 1, 2, 4, 7. There's a 2 in this column, and there's the 1 5 pair. So this has to be 4, 7. This is 1, 2, or 4. And I still need a 6 somewhere. So this 4 has to resolve, or maybe this 5. So the sum of those 5 digits is at most 21. But what happens if I make this a 1? If I make this a 1, the maximum is 1 plus 2, 3 plus 6, 9. And that's a maximum of 20 with 5 cells. So this has to be a 5. Now we get this 1, this 2, this 5. That here is a 1, which removes possibilities. That's not a 2, that's not a 2. This is 4, 6, or 7. This is 4 or 6. And now this 4 should finally resolve the whole stuff. 9 plus 1 is 10. If I put the 4 here, then I get a maximum of 21 for those 4 cells, so 4 can't be here. It has to go there. That's a 6, that's a 7. That's a 2, that's a 4, that's a 1, that's a 2, that's a 1, that's a 7. And this 6 and this 4, and a happy new year 2022. So I lost uncountable time not seeing that these 2 resolve the 2, 3 pairs. So that's embarrassing, but that's typical canard, as I'm used the same. So thanks for watching this video, and thanks to the Japanese author Shinichi Aoki for this very good puzzle and for this very good round, I must say. And see you pretty soon on SudoKanard. Here